Good morning, students. Today we are going to start with a new chapter, and that is electrolysis. The electrolysis is a part of electrochemistry. Electro means something to do with flow of electrons, or you can say electricity. Lysis means to split up. Now, how do I define electrolysis? Electrolysis is the decomposition of a chemical compound in the aqueous or molten state. Molten means fused state, in liquid state, by the passage of a direct electric current, that is DC, accompanied by a chemical change. Once more, electrolysis is the decomposition of a chemical compound in the aqueous or molten state by the passage of a direct electric current accompanied by a chemical change. Then we come across terms like electrolytes, non-electrolytes, strong electrolytes, weak electrolytes. So let us discuss one at a time. What do you understand by the term electrolytes? Electrolytes are chemical compounds which either in aqueous solution, which means dissolved in water, or in molten state, that means in liquid state, allow passage of electric current and produces a chemical change. Now, what are the examples of electrolytes? All the acids, for instance, dilute hydrochloric acid, dilute nitric acid, dilute sulfuric acid, these are electrolytes. Few I'm talking about, there are many more. Alkalis like potassium hydroxide, sodium hydroxide solutions, these are all electrolytes. They conduct electricity. Now, ionic salts like lead bromide, okay, this is fused state. Then copper sulfate solution, aqueous, then sodium chloride solution, etc. These are few examples of electrolytes. Now let us discuss non-electrolytes. Chemical compounds which do not conduct electricity in the fused state or in aqueous solution. Non-electrolytes are covalent compounds. Do not have ions, only molecules. So why do they do not conduct electricity? Because they do not possess free ions. They only consist of molecules. Example, distilled water, alcohol, kerosene oil, okay, then carbon disulfide, carbon tetrachloride, sugar solution, okay, glucose, urea, etc. These are few examples of non-electrolytes. Now, let us begin with strong electrolytes. Strong electrolytes allow a large amount of electricity to flow through them, hence are good conductors of electricity. They are almost completely dissociated in aqueous or fused state. That means it will decompose into ions. Almost all will decompose into ions. The solution contains almost free mobile ions. For example, all strong acids. Now when I talk about all strong acids, it means dilute sulfuric acid, dilute hydrochloric acid, dilute nitric acid. Then alkalis like sodium hydroxide solution, potassium hydroxide solution, and most salts of strong acids. Okay, most salts of strong acids. So like chloride salt, is that clear? Sulfate salt, these are some of the examples. Nitrate salts, these are some of the examples of strong electrolytes. Then let us discuss what is the weak electrolyte. Okay, weak electrolytes allow the small amounts of electricity to flow through them, hence are poor conductors of electricity. These are partially dissociated in fused or in aqueous solution. Generally, they contain ions as well as molecules. So, weak electrolytes are compounds that contain both ions as well as molecules. Acids are examples of weak electrolytes. Weak acids, when I talk about acetic acid is a weak acid, phosphoric acid is a weak acid, carbonic acid is a weak acid. Then weak bases, okay, there are a number of weak bases, okay, like copper hydroxide, magnesium hydroxide, lead hydroxide, whatever it is. Then salts of weak acids, okay. So these are few examples of weak electrolytes. Now, let us take a look at the electrolytic cell, which is also called a voltmeter. You see, there are two rod-like structures. The one that is connected to the positive terminal of the battery is called anode. And the electrode that is connected to the negative terminal of the battery is called cathode. In the electrolytic cell, you have taken electrolyte. So this is filled with an electrolyte. Is that clear? Now, there's a battery, right? So, and a bulb is there just to indicate whether the current is flowing or not. So the current, when it is switched on, it will flow from the positive terminal of the battery this way, that is anode, then to the cathode and back to the negative terminal. So the flow of current is in this direction, from the positive terminal of the battery to the negative terminal of the battery. So this is all for today. Please go through the definitions and learn the examples and do the assignment neatly and correctly. Thank you.